Welcome to Maths with El Profe Lo, working on some number theory using textbook from James Strayer, chapter 1. Doing some work with the Euclidean algorithm, okay, and we're going to go a step further now. We can say that, hey, that we can use the Euclidean algorithm to express the greatest common divisor of two integers in the form d equals ax plus by, where x and y are integers, okay? Now, this expression, the expression ma plus nb, right, m times a plus n times b, is said to be an integral linear combination of a and b. A lot of times that just gets shortened to a linear combination of a and b, but it's important to be familiar with the terminology, okay? So in other words, when you are asked to express the greatest common divisor of two integers as a linear combination of a and b, really what we're looking for is some x and y that are integers such that the greatest common divisor is equal to a times x plus b times y, okay? So a quick example to look at these steps, okay? So if we want to express the greatest common divisor of 803 and 154 as an integral linear combination of 803 and 154, right? Well, first we need to find the greatest common divisor, and we know it's 11 because of working through the Euclidean algorithm, right? That 803 is 154 times 5 plus 33. We work through this, and we're able to see, right, that the last non-zero remainder was 11, and so that's our greatest common divisor. Now, how the linear combination works goes in this form, right? We say, hey, this 11 is going to be 803 times 5 plus 154 times negative 26 because, all right, well, from this step right here, we're going to do back substitution. Well, what does 11 equal? Well, 11 is going to be 33 minus 22 times 1. Right? So 33 minus 22 times 1. All right? But what does 22 equal? 22 is 154 minus 33 times 4. So I take that 154 minus 33 times 4, and that's going to be substituted in there. And so then I could still write, of course, the times 1, but we know that times 1, you don't have to have that in there. All right, so 33 minus 22 times 1. If I do my distribution, negative times a negative is going to be a positive. So I have 33 times 5 minus 154. And of course, we could do the implied one there, okay? But what does 33 equal? Well, 33 is 803 minus 154 times 5. So now I take this and let's say, hey, that 33 is really 803 minus 154 times 5, right? And so really what we have is this 33 times 5, and apologies for all of these little arrows, that goes right over here, okay? So 83 minus 154 times 5 minus 154, and of course that implied 1. Okay, and once again, if we do distribution, 803 times 5, negative 154 times 5 minus 154, that's going to be 803 times 5 minus 154 times 26. So there we go. That 11 is going to be equal to 803 times 5 minus 154 times 26. But of course, we could say by the commutative property that that's 803 times 5 plus 154 times negative 26. So always be careful about writing these linear combinations, and we just work through, okay? So that expression of a greatest common denominator of two integers as a linear combination of those two integers is simply an exercise in using back substitution based on the Euclidean algorithm. However, it is important to note that this linear combination is not unique. You may wish to verify that 11 is equal to 19 times 803 minus 99 times 154, right? That we could come over here and say, okay, well, what is 19 times 803 minus 99 times 154? That is 11. So we are able to actually express this 11 in terms of this ax plus by in terms of many, in fact, an infinite number of x's and y's. But this process, using the Euclidean algorithm, will give us a solution always, okay? So we can go through and follow these steps. In another video later on, we'll discuss how we can find all the other types of solutions, right? But for this situation, we would say that x would be 19, y would be negative 99, okay? So in the next video, we're going to work through a couple of practice problems to ensure our understanding, okay? This is Maths with El Profe Lo.